Good morning, students. Now we discuss about the example 7.72. Sketch the graph of the function y equal to 3x by x square minus 1. Now first we discuss about the example 7.72. This is a problem. So y equal to, they give the functions y equal to 3x by x square minus 1. Now we sketch about the graph. That means we define, that means we find out the domain and the x-intercept, y-intercept, critical points, intervals of gravity. So everything we will find it from this functions. So now first I find out the domain and the range. So this is the function y equal to 3x minus 3x by x square minus 1. This is a function. So now first I find out the domain and the range. So domain and range are in the entire intervals except minus 1 and plus 1. So I take the domain of these functions. So y except minus 1 and plus 1 means you find out the domain means first you equate the denominator equal to 0. You take the denominator. Here you see denominator is x square minus 1. So x square minus 1 equal to 0. So x square equal to 1. X equal to plus or minus 1. X equal to plus or minus 1. 1 means x equal to minus 1 and x equal to plus 1. So if substitute both the value in the denominator, it goes to the 0. 0 means, so denominator comes to 0 means 1 by 0 infinity. So for that purpose, so the domain and the range only in the real numbers except minus 1 and plus 1, because we substitute minus 1 and plus 1 in the denominator, the function comes to infinity. So infinity, so no, that means infinity we not take. So for that reasons we avoid the minus 1 and the plus 1. So for that reasons I take the domain is real or minus 1 comma plus 1. Or minus means it is a or except. We know the real numbers. That means minus infinity to plus infinity, all the numbers included in the real numbers, but except minus 1 and plus 1. In that real number, no minus 1 plus 1. This is the meaning for or minus. This is not minus, or except. We call this or except minus 1 plus 1. That means minus 1 plus 1 not in the real number. Next, so this is a domain. Therefore, domain and the range. So next, x-intercept. Now I find out the x-intercept. X-intercept means we take y equal to 0. So I take the function 3x by x square minus 1 equal to, that means here if first you consider the function y equal to 3x by x square minus 1. Next you substitute x-intercept means when y equal to 0. So here you substitute 0. 3x by x square minus 1 equal to 0. Just doing the cross multiplication. 3x equal to x square minus 1. So 3x equal to 0 means x equal to 0. The next step, y-intercept. Y-intercept means you take the x equal to 0. So I substitute the above function y equal to 3x by x square minus 1. I substitute x equal to 0 in this function. 3 of 0 by 0 minus 1. So 0. 0 by minus 1, 0. So next it also passes through the origin, and next we got the answer 0, because x equal to 0, y equal to 0. So it is a passes through the origin. Next we find out the critical points of the function. So we need the critical points. The critical points condition is f dash of x equal to 0. So first I find out the f dash of x from the given function. The given function is f of x equal to 3x by x square minus 1. This is a given function. Now I find out the f dash of x. F dash of x equal to, this is a u by v method. So differentiation of u by v is b square into u dv minus b into du. So by x square minus 1 whole square into x square minus 1. So I differentiate the numerator. So the numerator function is 3x. So 3x whole dash minus, now I write the numerator 3x into, I write the denominator functions. Differentiate the denominator x square minus 1. Here whole dash will come, because now the second term we differentiate the denominator terms. So the next step, so you see in the next step, f dash of x equal to x square minus 1. That means 3x whole dash minus 3x into x square minus 1 whole dash by x square minus 1 whole square. So now I differentiate 3x whole dash. 3 into differentiation of x dash is x is 1. So 3 minus 3x into differentiation of x square is 2x, and differentiation of minus 1 is 0. So 3x into 2x. So the next step, now I multiply the 3 in the factor. So 3x square minus 3 minus 3x into 2x is minus 6x square by x square minus 1 whole square. The next step, f dash of x equal to, that means now I add the 3x square minus 6x square, adding the, because there is a two terms x square term, I adding that 3x square minus 6x square is minus 3x square minus 3 by x square minus 1 whole square. So the next step, the minus 3 is common, so I take from the numerator. So minus 3 into x square plus 1 by x square minus 1 whole square. This is the f dash of x. F dash of x equal to minus 3 into x square plus 1 by x square minus 1 whole square. So next step, f dash of x equal to 0. F dash of x equal to 0 means now this function is equal to 0. So minus 3 into x square plus 1 by x square minus 1 whole square equal to 0. Just doing the cross multiplication. Minus 3 into x square plus 1 equal to 0. So the next step, x square plus 1 equal to just minus 3 not equal to 0. So there is a only one here, one factor only, x square plus 1. Minus 3 is not any numbers not equal to 0, so we take only variables. So x square plus 1 equal to 0. X square plus 1 equal to 0 means x square, this plus 1 write in the right hand side minus 1. So x equal to this square, we write in the right hand side is square root. So x equal to square root of minus 1 has no real solutions, because the square root of minus 1 is plus or minus I. So x equal to plus or minus I. So x equal to plus or minus I means it is a imaginary solutions, no real solutions. Therefore f dash of x does not exist at x equal to minus 1 and plus 1. So hence the critical numbers are x equal to plus or minus 1. You see now the intervals are, so x equal to minus 1 and plus 1 I mentioned in the number line, minus infinity to plus infinity, minus 1 plus 1. So the intervals are minus infinity comma minus 1 comma 1 1 comma infinity. So minus infinity comma minus 1 minus 1 comma 1 1 comma infinity. Now I make the tables intervals minus 3 into, so the first column is intervals. The next f dash of x, we know that f dash of x equal to minus 3 into x square plus 1 by x square minus 1. So the numerator term is minus 3 into x square plus 1. The denominator term is x square minus 1 whole square. So now I find out the f dash of x. The next intervals of increasing or decreasing. Now first interval minus infinity comma minus 1 comma 1 comma infinity. So now that means I substitute any numbers from this interval. So suppose we substitute the x equal to minus 2. So x equal to minus 2 means minus 3 into minus 2 whole square plus 4 plus 1 5 into minus 3 minus 15. So the answer comes in the minus sign, so I represent the minus. So next again I substitute the x equal to 2 square, x equal to 2. So 2 square 4 minus 1 3 square 9. So the answer is the sign in the answer is plus. So next this is a minus by plus. So minus by plus means minus into plus, just we multiply minus. Therefore f dash of x come to the answer is minus sign. So next minus 1 comma 1. So from this interval you choose any number and substitute this functions. So I take the before this number, before the interval minus 1, after that 0, after that 1. So the middle value I take the x equal to 0. So I substitute in this function. X equal to 0 means here minus 3, so negative. Next x equal to 0 means minus 1 whole square plus, next minus into plus minus, next 1 comma infinity. 1 comma infinity means x equal to 2. So I substitute here minus 3 into 2 square 4 plus 1 5 into minus 3 minus 15. So minus, next 2 square 4 minus 1 3 square 9. So the answer is plus 9. So I write the symbol plus, and the next multiply both the symbol, that means minus into plus minus, therefore decreasing, because f dash of x comes in the sign minus means decreasing, minus decreasing. So next since there is no sign change in the f dash of x, hence no local extrema, because you see the sign of the f dash of x minus no sign, alternate sign, no sign changes, so we tell it is a no local extrema. Next, intervals of concavity. We need the intervals of concavity. We take the f double dash of x, so we find out the f double dash of x. From this we find out the intervals of, that means intervals of concavity. So first already we know, we differentiate the f dash of x. So I can, here in this step I consider f dash of x equal to minus 3 into x square plus 1 by x square minus 1. Now I take the f double dash of x. F double dash of x equal to, that means this is the first I square the denominator, x square minus 1 whole power 4. Now I write the denominator x square minus 1 whole square into, now I differentiate the numerator, so minus 3 x square plus 1 whole dash minus, next step I write the numerator minus of 3 into x square plus 1 into, next I differentiate this x square minus 1 whole square whole dash. So the next step, so f double dash of x equal to minus 3 into x square plus 1. So now I differentiate the numerator, so I got the answer minus 3 into 2x. Next I minus, that means minus 3x square plus 1 into, I differentiate the denominator. Differentiation of denominator is 2 into x square minus 1 into 2x. This is the differentiation of the denominator. So the next step, now I multiply minus 3 into 2x minus 6x, minus 6x into x square minus 1 whole square, minus into minus plus 3, that means 3 into 2 into 2 4x, so 3 into 4x 12x into x square plus 1 into x square minus 1, so by x square minus 1 whole power 4. In the next step, f double dash of x equal to, the next step, that means minus 6x square minus 6x into x square minus 1 whole square plus 12x into x square plus 1 x square minus 1. From the numerator I take the common factor, so the common factor is, that means 6x is a common factor, and the next x square minus 1 is a common factor. Therefore 6x into x square minus 1 is a common factor. So the remaining term is minus x into x in my, that means minus x, because 6x I take and next x square minus 1 I take, so remaining term is minus x square minus 1 plus remaining terms are, that means I take the 6x and into x square minus 1, so the remaining terms 12 I factorize into 6 into 2, so 2 into x square plus 1, so by x square minus 1 whole power 4. So in the next step you see x square minus 1 and x square minus 1 whole power 4 cancelled one time, that means so for 1 x square minus 1 left, so the remaining terms are, that means 6x into minus x square minus 1 plus 2x square plus 1. So just we add it, I multiply the minus, so minus x square plus 1 plus 2x square plus 2, so minus x square plus 2x square, remaining we add the minus x square plus 2x square plus x square plus 1 into plus 2 plus 3 by x square minus 1 whole power 3. This is a f double dash of x. Next f double dash of x equal to 0, because we find out the intervals of that means concavity. So concavity condition is f double dash of x equal to 0. Already we find out the, that means local extrema. So local extrema means we will take the, that means f dash of x equal to 0, but the concavity, the condition is f double dash of x equal to 0. So we need the concavity, we take the condition f double dash of x equal to 0. So I write the f double dash 6x into x square plus 3 by x square minus 1 whole cube equal to 0. The next step, and just I multiply the denominator into 0, so 6x into x square plus 3. So the next step, here two factors, 6x and x square plus 3, there is a two factor, so 6x equal to 0 and x square plus 3 equal to 0. So x equal to 0 and x square equal to minus 3. Therefore x equal to square root of minus 3, not real, this is not real. So therefore f double dash of x does not exist at x equal to minus 1 plus 1. So you see f double dash of x does not exist at a, because there is a square root of minus 3 is a root 3 I, it is the imaginary value. So f double dash of x does not exist at a x equal to minus 1 and plus 1. So next intervals are minus infinity comma minus 1 comma 0 0 comma 1 1 comma infinity. You see minus infinity comma infinity, so the numbers are, that means minus 1 0 1, so I substitute here. So therefore now intervals, there is a 4 intervals. That means the first interval minus infinity comma minus 1, minus 1 comma 0, and 0 comma 1, 1 comma infinity. So I substitute I enter all the intervals, and next we know that f double dash of x. So f double dash of x is 6x into x square plus 3 by x square minus 1 whole cube. This is the f double dash of x. So first I take the x and next x square plus 3. These terms are numerator term. Next I enter the x into x square plus 3. This is a numerator term. Next I write the denominator term. Denominator term is x square minus 1 whole cube. This is a denominator, numerator and denominator. So f double dash of x. So here this is the f double dash of x, because these terms are f double dash of x factor. That means f double dash of x equal to 6x into x square plus 3 by x square minus 1 whole cube. This is the f double dash of x. So the next step, now first I take the first interval minus infinity comma minus 1. So you take any numbers from this interval and substitute. Suppose I take x equal to minus 2. X equal to minus 2 means here I substitute minus 2. The sign in the answer is minus. So minus. Next to minus 2 whole square, here now I substitute x equal to minus 2 in this factor, x square plus 3. So x equal to minus 2. Minus 2 whole square is 4. 4 plus 3 7. So the sign in the answer is plus. Next minus 2 into minus 2 whole square plus 3. Minus 4 plus 3 7. 7 into minus 2 minus 14. So the sign is minus. Next x square minus 1 whole cube. I substitute x equal to minus 2. So 4 minus 2 whole square 4. 4 minus 1 3. So 3 whole cube is the that means 3 3s are 9, 9 3s are 27. So plus in the answer. So f double dash of x. F double dash of x is just this is the f double dash of x is 6x into, that means x square plus 3 by x square minus 1 whole cube. The last two terms. So we just multiply this, minus into plus minus. So you don't multiply all the symbols, because we just substitute in the f double dash of x. F double dash of x equal to 6x into x square plus 3 into x square minus 1 whole cube. So x into x, the numerator term sign is minus, denominator term sign is plus. So minus by plus is minus. So next you take the interval minus 1 comma 0. So minus 1 comma 0 means you take the in the middle value. So that means you take the any values. That means you substitute minus 1.5. so you substitute the x equal to minus 1.5, you get the answer minus sign. So again you substitute any number from this interval in the all the factor. So our sign is plus, minus, minus, and the next f double dash of x equal to minus by minus is plus. Next 0 comma 1. So 0 comma 1, again you take the any numbers from this interval. Suppose you take x equal to 0.5, 1 by 2. So 1 by 2 means you just x equal to 1 by 2. You substitute here 1 by 2. The sign is plus in the answer. So plus. Next x equal to 1 by 2. 1 by 2 whole square plus 3. 1 by 4. 1 by 4 plus 3. So 4 3s are 12. 12 plus 1 13. 13 by 4. So that means 13 by 4, it is a plus in the sign is plus in the answer. Next x into x square plus 3. Now I substitute x equal to 1 by 2. So 1 by 2 into 1 by 2 whole square 1 by 4. So already we find out that means 1 by 4 plus 3, that means 13 by 4 into 1 by 2. Okay, 13 by 4. So 13 by 8. So again that means here x equal to, we substitute. So x equal to plus 1 by 2. So the sign is plus in the answer. So I write it plus. Next I substitute x equal to 1 by 2. So 1 by 2 whole square 1 by 4. 1 by 4 minus 1. I just cross multiplication. So 1 minus 4 by 4. So minus 3 by 4. So the sign is minus. So therefore f double dash of x equal to numerator by, this is a numerator, this is a denominator. So numerator by denominator is plus by minus. So next 1 comma infinity. So we take any numbers from this. I take x equal to 2. So x equal to 2 means here I substitute 2 means the sign is plus. Next 2 square is 4. 4 plus 3 7 plus. Next 2 into 4 plus 3 7. 7 2s are 14 plus. Next 4 minus 1. 4 minus 1 is 3 cube 27 plus. Next f double dash of x equal to plus by plus is plus. Therefore you see there is a minus sign downward, concave downward. plus means concave upward, minus sign means concave downward, plus sign means concave upward. So we find out the concave. So we need the concave, we take the f double dash of x equal to 0. From this you find out the intervals and substitute the any numbers from this the all the factor. We get this last sign is minus plus minus plus. So minus means we represent concave downward, plus means we represent the concave upward. So next the point of inflection, or now we find out the point of inflection. So that means f double dash of x equal to 0. So f double dash of x equal to 0 means you take the, that means we know that f double dash of x 6 into x square plus 3 by x square minus 1 equal to 0. Therefore 6 into x square plus 3 equal to 0. So x equal to, that means x equal to numerator term x equal to 0 and x square equal to minus 3. So x square equal to minus 3 means x equal to square root of minus 3 is there, it not real answer. So we take only x equal to 0, it is the real answer. So therefore x equal to 0 in y. So I substitute in the function y equal to, that means 3x by x square minus 1. Here I substitute x equal to 0, our answer is 0. Therefore the point of inflection is 0 comma 0. This is the answer for point of inflection. So next asymptotes. So now we find out the asymptotes. So that means the denominator term is x equal to x square minus 1. So x square equal to 1, that means x equal to plus or minus 1. I take the x equal to 1. So x tends to 1, limit x tends to 1, y equal to limit x tends to 1, that means I substitute the function 3x by x square minus 1. I substitute 1. So the limit is x tends to 1 plus means right hand limit. So I substitute x equal to 1 means 3 into 1 by 1 minus 1. 1 minus 1 is 0. 3 by 0. 1 by 0 is infinity. So next I substitute, that means limit x tends to 1 minus, that means the left hand limit. So y equal to limit x tends to 1 minus means you take 3x by x square minus 1 means you substitute 1 by 1 square. 1 minus 1, it is here infinity, but the right hand left hand limit is minus infinity because we take the left side, so it is a minus infinity. Therefore we plus infinity and minus infinity, this is a vertical asymptotes, because the vertical asymptote answer is plus or minus infinity, plus or minus infinity. Therefore limit x tends to minus 1 plus, again I substitute the, because the x answer is x value is plus 1 and minus 1. So I substitute the plus 1, I got the plus infinity and minus infinity. The line represent the vertical asymptotes. Next now I substitute the x equal to minus 1. So x equal to minus 1 into y means I take the, our answer is just substitute x equal to minus 1. 3 into minus 1 and the minus 1 whole square is, denominator is 1. 1 minus 1 0. Again denominator is 0 means it comes to infinity. So left hand limit means you take the past infinity, and again you substitute minus 1. So minus 1 means you take the minus 3 by 1 minus 1. 1 minus 1 0. So 1 by 0 infinity. So it is a left hand limit. Left hand limit means minus infinity. Therefore one right hand limit and the left hand limit, you see both the answer are same. Therefore x equal to minus 1 and x equal to 1 are vertical asymptotes. Both the line are vertical asymptotes. Therefore x equal to minus 1 represent the vertical asymptotes and x equal to 1 represent the vertical asymptotes. Therefore this is a curve for the vertical asymptotes. So now we discuss about the exercise 7.9. Find the asymptote of the curve f of x equal to x square by x square minus 1. So you see, find the asymptote of the curve f of x equal to x square by x square minus 1. So now I take the limit x tends to minus infinity into f of x equal to limit x tends to minus infinity. F of x means x square by x square minus 1. So now the numerator I take the x square by x square, denominator I take the x square minus 1 by x square. So limit x tends to minus infinity. So the next step, limit x tends to minus infinity into x square by x square is, that means 1 x square by multiply and divide by x square. So 1 x square I put in the numerator and 1 x square put in the denominator. So I write it x square by x square is 1, and now this is in the denominator, x square divide all the numerator terms. So I write it x square by x square minus 1 by x square. So limit x tends to minus infinity, 1 by 1 minus 1 by x square. Therefore 1 by 1 minus, that means now I substitute x tends to, here I substitute x tends to minus infinity. So minus infinity whole square, it is a infinity, 1 by infinity 0. So our answer is 1. in the minus infinity. Next I substitute the plus infinity. Limit x tends to infinity, f of x equal to limit x tends to infinity. Now I substitute it. That means here I substitute plus infinity. So x square by x square minus 1 equal to limit x tends to infinity, x square. Again that means I take the numerator and multiply and divide by x square by x square. So I write it x square by x square and x square minus 1 by x square. This denominator cancelled. Again it comes to the previous step. So I write it this steps I write it this way. That means x square by x square minus 1 by x square, because here you see this in the denominator x square and denominator x square cancelled. So I write it x square by x square minus 1. So the next step, now x square by x square is 1, and in the denominator x square divide the numerator x square by x square minus 1 by x square. So limit x tends to minus infinity, that means 1 by 1 minus x square. So the next step you just substitute x equal to infinity. So 1 by infinity square infinity, 1 by infinity 0. So 1 by 1. So 1 by 1 is, our answer is 1. So you see both the answer are same. That means limit x tends to minus infinity equal to 1, limit x tends to plus infinity equal to 1. So both the answer are same. Therefore the line represents the horizontal asymptote. The curve passes horizontal asymptote at y equal to 1. Therefore from this, wait till it is a horizontal asymptote means because limit x tends to minus infinity f of x and limit x tends to infinity f of x, both the limit answer is same. So from this I conclude that the curve passes through horizontal asymptote at y equal to 1. Next we discuss about the we will prove about the vertical asymptote. The vertical asymptote condition is limit x tends to a minus f of x equal to plus or minus infinity, limit x tends to a plus f of x equal to plus or minus infinity. Therefore limit x tends to minus 1. So minus 1, the left hand limit is f of x equal to, we just write the function x square by x square minus 1. Now I substitute x equal to minus 1. This power minus represent the left limit, that's all. So now I substitute x tends to minus 1 means I substitute x equal to minus 1. So minus 1 whole square is 1. So now I write the, and the next one here I substitute minus 1 plus 1 0. So 1 by 0 infinity. Now that here you see the limit minus 1 power minus means it represent the left limit. So my left limit means we take the minus infinity. So the left hand limit of the infinity is minus infinity. So next I take the limit x tends to minus 1 power plus. So this represent the plus represent the right hand limit. Therefore into f of x, limit x tends to minus 1 whole power plus f of x is x square by x square minus 1. So limit x tends to minus 1 whole power plus x square into I factor this, the I factor is x square minus 1 is x plus 1 into x minus 1. Now I substitute minus 1. So here I substitute minus 1 plus 1 is 0. So 1 by 0 is infinity. Now I take the right hand limit of infinity is plus infinity. So you see both the answer is same. That means not same, it is a minus infinity and a plus infinity, but it represent the vertical asymptotes. Therefore because the vertical asymptote condition is plus or minus infinity, the answer will come plus infinity or minus infinity, plus infinity, any that means out of these two any one will come. So here minus infinity and plus infinity. So according to the vertical asymptotes, I conclude that means the curve passes vertical asymptotes at x equal to plus or minus 1. This is the curve. So vertical asymptote, this is the x equal to minus 1 vertical asymptote, x equal to 1 is the vertical asymptote. So the curve is this one. So this is a curve. The curve passes through the vertical asymptote at x equal to minus 1 and at x equal to 1. Now second one, f of x, find the asymptote of the curve f of x equal to x square by x plus 1. Now we find out the asymptote. Asymptote means it is a vertical and horizontal asymptote. Now we will find out that. So first the given function is f of x equal to x square by x plus 1. So now this is the condition, this is the horizontal asymptote conditions. Horizontal asymptote equal to limit x tends to plus infinity f of x equal to L. Limit x tends to minus infinity f of x equal to L. That means plus infinity minus infinity, answer is L, the same answer. So we tell it is a horizontal asymptote. Vertical asymptote means limit x tends to A a left hand limit left hand limit of a, that means f of x plus or minus infinity, limit extends to right hand limit of a, f of x equal to plus or minus infinity. This is a vertical asymptote. So now I take the limit extends to plus or minus infinity f of x equal to, now I take the limit extends to, that means infinity minus, it is represent the left hand limit, so into x square by x plus 1. Now I substitute x equal to infinity. Infinity means here substitute infinity under denominator, that means by infinity plus 1, so the answer is infinity. So next I substitute the curve does not passes through the horizontal asymptotes, because the answer is so next one, here I substitute, that means x equal to minus infinity minus, that means left hand limit, we get the answer infinity. So next the curve does not passes through horizontal asymptote, so therefore so next limit extends to minus 1, so minus 1 means we substitute in the function x square by x plus 1, so x square means minus 1 whole square by minus 1 plus 1, so minus 1 plus whole square is 1 by minus 1 plus 1 is 0, so 1 by 0 infinity. So now that means the left hand this is the minus 1 whole power minus, this represent the left hand limit, so the left hand limit of infinity is minus infinity. So next limit extends to minus 1 plus, this represent the right hand limit, so into f of x equal to limit extends to minus 1, this function is x square by x plus 1, so here I substitute minus 1 whole square is plus 1, minus 1 plus 1 is infinity, so that means here minus 1 plus 1 is 0, so 1 by 0 is infinity, so the right hand limit of infinity is plus infinity. So you see both the answer is same, that means the vertical asymptote, the answer will come plus or minus infinity and plus or minus infinity. So this minus infinity we take the plus or minus infinity, this plus infinity we take the plus or minus infinity, answer both are same. So the answer both are same means the curve passes vertical asymptote at x equal to minus 1. Therefore next we calculate the slant asymptote. Slant asymptote means now the numerator there is a 2 polynomial, so the numerator degree is higher than the denominator, because the degree of the numerator is 2, the degree of denominator is 1, so the numerator polynomial degree is higher than the denominator. So so x plus 1 divide the x square, so now I write it the long division, using long division method I put the inside of the box, I write it x square, outside I write it the denominator, inside I write the numerator, outside I write the denominator. Now just x square, so now we convert the x plus 1 into this, we convert this x into x square, so we multiply x into x plus 1, so x square plus x. So the next step minus, that means now we change the sign, minus minus, so cancelled, so minus x. So therefore in the next step again, so again this plus x we write it the minus x, so just I multiply the minus 1, so minus x minus 1 we add it, so our answer is minus x plus x cancelled, our answer is plus 1. So therefore so our answer is plus 1, therefore see our answer is plus 1, not answer, it is a remainder is plus 1, so the answer is x minus 1. X minus 1 is a slant asymptote, therefore y equal to x minus 1 is a slant asymptote. This is the answer for slant asymptote. This is the condition for slant asymptote curve. This is the curve for slant asymptote. So this is the curve passes through the slant asymptote, both the curve passes through the slant asymptote. Slant asymptotic equation is y equal to x minus 1. Now you see the third subdivision, f of x equal to 3x by square root of x square plus 2. So horizontal asymptote condition is limit extends to plus infinity f of x equal to L, limit extends to minus infinity f of x equal to L. So now I write the function f of x equal to 3x by square root of x square plus 2. So in the next step I write the f of x equal to 3x by, I take the one in the denominator, I take the x square from the outside, so I write it x square from this term, so x square into, I write it the 1 plus the second term, I take the x square from this term, but the second term no x square, so I write it x square plus, I write it plus 2 into x square by x square. So I take the 1 x square from this two terms. So I write it x square into 1 plus the numerator x square comes to the outside, so I write it 1 plus 2 by x square. So in the next step 3x by, that means now I take the square root of x square into square root of 1 plus 2 by x square. So the next step is square root of x square is mod x, so 3x by square root of 1 plus 2 by x square. So limit extends to minus infinity f of x. Now I take the minus infinity, the limit is minus infinity, limit extends to minus infinity f of x equal to limit extends to minus infinity f of x is 3x by, that means the function is 3x by mod x square root of 1 plus 2 by x square. Now I take the 3x, the modulus of the mod value we take the minus x, because it is a minus left hand limit we take, so we represent the minus x. So the minus infinity represent the left hand limit, so the left hand limit of mod x is left hand is minus x. So 3x by minus x square root of 1 plus 2 by x square. So limit extends to minus infinity. Now x cancelled, so minus 3 by square root of 1 plus 2 by x square. Now I substitute the infinity, x equal to minus infinity. X equal to minus infinity means I substitute the infinity, that means 1 by infinity 0. So I write it, that means 3 by square root of 1, 3 by 1, therefore the answer is minus 3. Therefore limit extends to minus infinity f of x equal to minus 3. This is your answer. Next, now we check it the vertical asymptote. Vertical asymptote is limit extends to a minus. A minus means it is a left hand limit of a. So f of x equal to plus or minus infinity, limit extends to a plus f of x equal to plus or minus infinity. Now limit extends to infinity f of x equal to, now I substitute the x in the functions. So I substitute x equal to infinity in the factor. So I write it 3x by, here mod x I write it the plus x, because it represents the x tends to infinity means it represents the right hand limit. So right limit of mod x is plus x, left limit of mod x is minus x. So here I take the plus infinity means I take the positive, so x cancelled. 3 by square root of 1 plus 2 by x square. Next I substitute the x equal to infinity, so 1 by infinity is 0, so I write it 1 plus 0 3 equal to 3. The curve passes horizontal asymptotes at y equal to, so the horizontal asymptote at the point y equal to 3 and y equal to minus 3. So therefore this is the horizontal asymptotes, y equal to 3 and y equal to minus 3, and the curve passes the horizontal asymptotes at the point y equal to 3 and at the point y equal to minus 3. Therefore f of x equal to 3x by square root of x square. I write it the given function 3x by square root of x square plus 2. So the next step, denominator equal to 0, x square plus 2 equal to 0. Therefore here x square equal to minus 2, x equal to plus or minus square root of minus 2. Square root of minus 2 is, that means it is a imaginary answer, that means I into root 2. So therefore f of x cannot be infinity. So f of x cannot be, it is not comes to the infinity. So now we discuss about the fourth subdivision, f of x equal to x square minus 6x minus 1 by x plus 3. Now you see f of x equal to, I write the given function f of x equal to x square minus 6x minus 1 by x plus 3. Now I take the left hand limit, that means you take the denominator, x plus 3 equal to 0 equal to x equal to minus 3. So therefore limit extends to minus 3, power minus means it represents the left limit. So into f of x, limit extends to minus 3. So into f of x limit extends to minus 3. Now I write the function x square minus 6x minus 1 by x plus 3. So now I substitute x equal to minus 3. I substitute here. So minus 3 whole square into, that means minus 6 into minus 3 minus 1 by minus 3 plus 3. So minus 3 whole square means minus 6 into minus 3 minus 1 by minus 3 plus 3. Therefore minus 3 whole square is 9, minus into minus plus 6 3s are 18, minus 1 minus 3 plus 3 cancelled, so 0. So 1 by 0, that means we write it, it is a 3 square 9, next plus 18 and minus 1. So we add it and we cancel the 9 minus 1 18, 8 plus 18 is, it is a 26. Therefore 26 by 0 is infinity. Now here we see the it is a left limit. So left limit of infinity is minus infinity. So next I take the limit extends to minus 3 plus means it represents the right limit. So limit extends to minus 3 plus f of x equal to limit extends to minus 3. I write the function x square minus 6x minus 1 by x plus 3. Now I substitute the x equal to minus 3. So x equal to minus 3 means the same answer. That means we get the answer infinity. Now the right limit of infinity is plus infinity. So this is you see both the answer is same. Therefore there exists a vertical asymptote. Now we find out the slant asymptotes. Slant asymptotes means the polynomial in the numerator is a higher degree than the polynomial is the denominator. You see polynomial in the numerator is a higher degree than the polynomial in the denominator. So here you see this is a function. So the numerator polynomial, this is a numerator polynomial, this is a denominator polynomial. Degree of the numerator is 2, degree of denominator is 1. So the degree of the numerator is higher than the degree of denominator. Therefore, so now I divide the x square minus 6x minus 1 by x plus 3. So I put inside now I take the long division method. So inside I write the numerator polynomial, outside I write the denominator polynomial. So x square minus 6x minus 1 and this polynomial divided by x plus 3. So I write it outside. So now I write the x in terms of x square. So x into x square means we need 1x. So I multiply the x into x plus 3. So x into x square plus x into 3 plus 3x. Now I change the sign, minus minus. So x square minus x square 0. Next minus 6x minus 3x minus 9x minus 1. The next step. Now again you see there is a minus 9x. You add these two terms, we get the answer minus 9x minus 1. So again now there is now I convert the x into minus 9x. So x and here also x, but we need the minus 9. So we multiply the minus 9 in this factor. So I write minus 9 into x minus 9x plus into minus 9 3s are 27. Therefore now we change the sign, plus plus. Therefore we write it minus 9x plus 9x. It comes to 0 and minus 1 plus 27. Minus 1 plus 27 is 26. Therefore remainder is 26 and the quotient answer is x minus 9. Therefore the slant asymptote is x minus 9 is a slant asymptote. This is a slant asymptote. Y equal to x minus 9 is a slant asymptote. So this is a slant asymptote. The line y equal to x minus 9 is slant asymptote. The curve passes these two curve passes the slant asymptote. This is a diagram for slant asymptote, and vertical asymptote is x equal to minus 3 represent the vertical asymptote. This yellow color line represent, yellow color dotted line represent the x equal to minus 3 represent the vertical asymptote, and y equal to x minus 9 represent the slant asymptote. This is the diagram for asymptote. We complete the class.